So we're going to take our information that we've been learning so far about right triangles and apply them to a couple of examples. The first example we're going to look at says I want to solve the right triangle ABC if I know that the angle B is 28 degrees 40 minutes and I know angle side A is 25.3 centimeters. So let's start by drawing the triangle since it's not given to me, and I'm going to make the assumption that angle C is going to be my right angle. So I'm coming down here. I've got angle A, B, and C because C is going to be my right angle. And then I'm told in the problem that angle B is 28 degrees 40 minutes and side A is 25.3 centimeters. So when I am told that I need to solve the right triangle, what I'm actually looking for is I need to be able to state or fill in all of the missing sides and angles. So I'm going to start with the most obvious, and that is the angle measurements. I already have two of the three angles filled in, so let's start by finding the missing angle A. I know because it's a right triangle that angles A and B are co-functions or complementary angles to each other, I should say. So both of those angles should add to be 90 degrees because that's the remaining value out of the 180 available. So if I let angle A be equal to 90 minus 28 degrees 40 minutes, let's go find that value on the calculator. So this is going to be 90 minus 28 degrees and 40 minutes. So that's the decimal value that I ended up with, but because the angle in the problem was given to me as degrees, minutes, and seconds, I need to return it in the same form that it was given to me as. So I'm going to convert that decimal value into degrees, minutes, and seconds, and I can see that it is 61 degrees 20 minutes. So we're going to go ahead and record that as 61 degrees 20 minutes. Now, I've got the angles figured out here. Let's go in and let's figure out what the remaining sides are. I can't use Pythagorean's theorem on this because I only have one side out of the three available. So this is where our right triangle trigonometry, the definitions that we've been working on, SOHCAHTOA, are going to come in handy for us. Now, I have two angles that I now know here, angles A and B, that I can apply SOHCAHTOA to, but I want to start with, or I want to actually use the angle that was given to me in the original problem. It's always best to go back to what was originally given, not something that you actually calculated, because it's less likely to lead to errors. So I know that I want to be dealing with angle B, and I've got some choices here, right? So SOHCAHTOA, I can choose sine, cosine, or tangent. So if I'm looking at sine, I would have to have opposite over hypotenuse of angle B. So that means I would have to have this side as well as the hypotenuse available to me to solve, or one of them I should say, to be able to solve, and I don't have those yet. In fact, that's what I'm looking for. If I have cosine, that gives me the adjacent side and the hypotenuse, and I can solve for the hypotenuse if I wanted to use cosine, or I could use tangent, which would be opposite over adjacent. Opposite over adjacent. And it doesn't really matter whether you chose to use cosine or whether you chose to use tangent. So let's just choose to use, I don't care, let's use cosine. So because it was just right there. So if I wanted to know if I was saying the cosine of angle B has to be equal to adjacent, which would be 25.3 over side C, little c, right? And I know what B is, I know what angle B is, so we're going to rewrite this as the cosine of 28 degrees 40 minutes must be equal to then 25.3 over C. Now it's just an algebra problem. I have one unknown thing here, that's C, that's the variable I'm solving for. So I'm going to multiply both sides by C. And what I end up with is C times the cosine of 28 degrees 40 minutes has to be equal to 25.3. Now I'm trying to get the variable c by itself, so I'm going to divide both sides by 28 degree, the cosine of 28 degrees 40 minutes. And now that's going to leave me with c on the left, and I'm going to let the calculator take care of what was on the right. So we'll pull the calculator up. Let me move it, or leave it there. And so what I'm going to do is I'm going to take the 25.3 divided by the cosine. So 25.3 divided by the cosine of 28 degrees 40 minutes. My calculator's already in degree mode because I haven't changed it from the last time I used it. So that's the one thing that you need to check for. When I take that calculation, I find out that C, side C, if I was rounding to 1 decimal place, is 28.8. So C is 28.8 centimeters. Now, at this point, I have a couple of options. I can come back in and I can use TOA, tangent, in order to find the missing side that you see here, the side B, or I can just use Pythagorean's theorem because I've got 2 out of the 3 sides already calculated. So let's come down here and let's do that. I've got a squared plus b squared is equal to c squared, or in other words, a squared, which would be 25.3 squared, plus b squared is equal to 28.8 squared. So b squared is equal to 28.8 squared minus 25.3 squared. And then when I take the square root of that, I'll know what b is. So let's do that on the calculator. So I have 28.8 squared minus 25.3 squared, and then I'll take the square root of that, and I find out that side B is 13.8 when I round up. So I found 13.8 centimeters. So what I was asked to do in this problem was I had to find the missing angle as well as the missing sides. So the missing angle occurred at angle A, and the missing sides were sides B and C. And so that's how we're using SOHCAHTOA to solve this right triangle.